Hello.
Hello.
Hello, Eric. Hello, Ryan. Happy New Year. Okay. So what we have learned yesterday?
Heap.
Yeah, heap and
I did it first. Last time.
Yeah, there's no
Yeah, we
last
did it.
time.
Yeah.
Okay. Heap and priority queue. What's priority queue?
The smallest number.
First in, priority out. Yes. Yeah. Okay. So today we.
That's about priority queue.
Yeah, priority queue. So so you given each number. Each element in the queue has been given a priority, and then when we dequeue, we call it dequeue. This dequeue is to get the pop an element from the queue, right? So it will take the highest priority, right? Okay. So now this is very useful. For example, that if we have a problem like this, if we have a few sticks, yeah, with different lengths. 2, 4, 3. And then each time I ask you to merge two of them. For example, if I merge to put it together to connect. For example, if I take a 3 and 4, 3 and 4, yeah, you become 7, yeah. So now the stick will be 7 and 2. But the cost to do that is 7. Okay, yeah. And then now I have a 2 and 7, and I connect it, it will be 9, right? The cost will be 9, right? So when there is only 1, we end the game, and the cost will be 9 plus 7, which is 16, yeah? Alright? So can you think of a way to do this with the minimum cost? Do you get it? For example, if this you add put the add and 3 and 4 together, that will be 7, yeah? The cost will be 7, yeah? And then 7 plus 2 equals 9. The cost will be 9. So altogether, the cost will be 16. Okay? And another way of doing it, if I do these 2 and 3 together, 2 plus 3, they'll become 5, yeah? Cost will be 5, yeah? Sorry? And then 5 plus 4 equals 9. And the cost will be 9. So the cost is 14. Get it? So this is better than this. Do you get it? Yeah? So every time we pick 2, we merge it, we connect it to each other, and the cost will be the total length of this, the new stick after merge. And when there's only one, when every sticks are merged into one, and then we end the game, and the cost will be the total cost after at each merge. Do you understand this problem?
Yeah.
Yeah, Eric? So any idea? Any idea how can we do it? Do you have a strategy? How can we do it with the minimum cost? So obviously this is 16, this is 14.
I think you just add the 2 smallest.
Wow, well done. Why? Yeah, it's true. You always pick the smallest. Yeah? Yeah? I can tell you why this is a good strategy. Greedy, yeah, greedy. How
makes
greedy?
me hungry.
Yeah, greedy. So pick the two smallest every time. Two smallest. Yeah, two smallest. Okay, so for example, if we have a 4, for example, 4. A1, let's call it A, B, C, D. Okay.
A, B, C, D, E,
Just 2 lengths. If there are 4 lengths, and let's merge it from the left to the right. Let's merge it from the left to the right. So for first of all, A plus B, yeah? The cost is A plus B, right? This is the cost we want to add. And then now...
I don't know what's A plus B.
Yeah, it's just simple. We don't know the value, but it's A plus B. And then A plus B plus C, the cost will be A plus B plus C, right? Yeah? And then another merge. A plus B plus C plus D. The cost will be A plus B plus C plus D. So how many A, how many B, how many C's?
There's
3A, 3B, 2C, 1D. Okay, so these are 4 numbers, and this A and B needs to times 3 times, and the C is times 2 times, and D times 1 time. So if these are the smallest, the cost will be the smallest, yeah? If these are biggest, if A and B are the biggest, the cost will be biggest, yeah? So the A and B must be the smallest, am I right?
Yeah.
Yes? Do you get it? Look, if we if we this put it 1, 2, 3, 4. So this A will be what?
3.
No. A.
What?
A will be I will be choosing 1, right? Because if I choose 2, or choose A and B will be 1 and 2. If I choose 4, the cost will be maximized, right? Because it's times 3 times, right?
Yeah.
3 times A times plus 3 times B. So A and B must be 1 or 2. And then 2C will be 2. Look, if 2 times 3 plus 4, and then 2 times 4 plus 3, which one is bigger? This is 10, this is 11. Of course, I need to, because this times 2, so C should be smaller, right? Got it? Because 2 times C plus D, if C is 3 and D is 4, obviously I want the C smallest because it's times 2, right? If you pick the 4, that will be 2 times 4, bigger than 3, am I right? Yeah? Bigger than picking the 3, you got it? Yes? So the strategy, I just proved that it's always optimum to pick the 2 smallest in the selection first, okay? So how can we do this? How can we implement this? Using the heap. Yes? Using the heap. How do we do this? Define. Let's call it cost, okay? Mean cost.
Oh.
And let's call it sticks. Okay, sticks. Let's just call it S, okay? Right? So this is an array. How about we make it a heap? And every time priority queue. Every time I pick a 2, and it will be always smallest. Am I right?
Yeah.
And then I add it, I merge it, and I put it back to the stick. Am I right? How can we do this? Remember? Heapify, right? Heapify, HQ.heapify. Import, remember Eric? Import heap Q as HQ, okay?
Are you doing line 2, then line 3, then line 1?
Yeah, I just forgot. Yeah, heapify, and then S. And now the S will become a heap. And why we still have more than 1 sticks?
Yes.
Yeah, more than 1 stick.
Yes.
Then we need to get 2 from the. from the stick. Look, 2 from the stick. Look, A B equals HQ dot heap what? Heap what?
Pop.
We're done. Wow, you do pay attention to the class, right? Did you? Heap pop S, right? And then another one. HQ. This is the same. I just copied another one. This is the same as this. So heap pop writing it twice. So I have 2 numbers from the 2 smallest from the sticks, and the cost. I need to put the cost. Look, the cost is here, right? Cost equals 0, and then cost it will be equals what?
Cost will be equal.
Cost plus equals A
Heap
plus
B.
B. Okay, then now I need to add the A plus B. This is the new stick. I need to put it back to the keeper, right? Yeah, because it becomes a new stick. So now what?
Heaper.
HQ dot heap. Heap what?
Pop.
Push this S to the A plus B.
What's a heaper?
Sorry?
Why the heap? Past.
Oh, push, sorry. Push. And then return what? Return
Heap.
Return what?
Cost.
Cost. We are calculating this.
Why does that look?
Oh, cost. Cost. Okay, so
Heaper.
so what's the complexity?
Again.
No.
Again.
No.
Again.
No, you're just guessing. Look, there are n elements in the sticks, yeah?
Yeah.
So it needs n, but every time we are popping and push, it takes log n, remember? So this is n, this is log n. So altogether,
And log n.
yeah, n log n. Got it? It takes, remember we talked about yesterday, it takes log n to push and pop because it takes time to log n time to rebuild the heap, right? Yeah, rebuild the heap, the binary heap. Remember, if you delete this node, yeah, it takes log n time to pop up to rebuild this the tree, right? Yeah, the heap, the root of the heap is minimum, the smallest. Let's call the mean heap. If the root of the binary heap is the maximum, it's called what? Max heap. Got it?
Yeah.
Okay, let's do the coding.
Hey.
Coding time. Coding time.
Hey. Hey.
Keep quiet.
Hey.
Okay, wait. Sit down. Can you see it?
Yeah. Can you see it, guys? Yeah.
PI. 1, 2, 3, 4. Okay, so this is my channel, yeah?
And welcome.
Okay, so good. Can you not stay there because it's you're blocking the views. Okay, so let's do this quickly. So VIM, let's create called the sticks for PI, right? Okay, so now we have a stick 2, 2, 4, 3. Remember? 2, 4, 3. Yeah. So the answer will be 14. Remember? We just showed you it's 14, right? Yes. Okay, so let me.
Tuesday the 9th of January.
Is it clear? Is it clear? Yeah. It's clear. Yeah.
Let me see.
It's clear. Yeah. It's clear.
Let me see.
Okay, so now define. Yeah. Import. Let's import heap q as HQ. Define mean cost as, and we cost equals 0, right? Then we need to heapify the HQ dot heapify, make it a heap. And then when there's more than one heap, one stick, what do we do? A, B, we pop it. HQ dot heap, one, pop, right? And another one, right? HQ dot heap, pop. And then cost what? Cost what?
Cost and equal A plus B.
We're done. And then we need to put HQ dot heap push as what?
S, comma A and B.
Okay, and then return.
Cost.
Okay, let's do this. Print mean cost as
Python.
14. You see? Got it? Yeah.
Yes.
Yeah.
Yes.
So
Is that cat sticks?
yeah.
Matchstick manor.
Cat-
Matchstick cat
what?
and dogs.
Cat is to display the file content. Okay, so if you look this thing, VIM is to edit it. So this is the program about today. The complexity is
Again.
and why is that? Why is that?
Because you need to pop and push and take you time.
N log n. Yeah, n is the number of the stick in the original array, right? So how about if we let's try this? Let's try maybe just put some numbers. Yeah.
Blah 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 blah.
We don't know. Yeah, but this is
51.
yeah because it's look. Basically, you pick the 2 and 3 first. But let's do one more small one. Let's like 1, 2, 3, 4. Okay.
Yes.
So what's the answer? It's 19. Why is that? 1 and 2, that will be 3. Cost will be 3. 3 and 3, cost will be 6. Yeah, 6 plus 3. Yeah, and then 6 plus 4 will be 10. And then there will be 10 plus 9. That will be 19. We're done. Okay. Good job today. Good job today. Good job today.
Bye. Bye.
Don't shake. Don't shake. If you shake, I can't see it. Okay.
No.
Okay. Say bye bye.
No.